Welcome to the fall session of the ICS Joint Working Group. My name is Jen Fowers, and I will be the moderator today. The session is Cyber Risks to ICS. There are two tracks in the educational series, Foundational and Advanced. This session is part of the Foundational track, and next week's session will be part of the Advanced track. Before I turn the time over to Gary Finco, our presenter for today, I would like to make you aware of a couple of features in this webinar platform. We will be using the questions panel. This is on the right-hand part of your screen. If you're unable to see the full questions submitted, you can undock the panel by clicking on the square with the arrow out next to the X on the right-hand side of the panel. Once that is done, you can enlarge the panel to view everything. Please submit your questions throughout the presentation so that after the presentation, when we have our Q&A session, we will be able to answer those questions submitted. At that time, we'll also be opening it up to live questions. If you have a question that you would like to ask live, please use the hand raise feature next to your name in the attendee panel. I will be able to see you raising your hand, and I will be able to call on you and unmute you so that you can ask your question. This session is being recorded and will be sent out in an email with instructions on how to access the recorded session. With that, I will turn it over to Gary Finco.
Hello and welcome to the Cyber Risks to Industrial Control Systems course. My name is Gary Finco and I am an instructor at the Idaho National Laboratory. Prior to joining INL in 2005, I worked for ABB in Sugar Land, Texas for 20 years. We designed, built, and installed SCADA EMS systems for electric utilities. I was introduced to INL when I was assigned as project manager to have our SCADA EMS system assessed for cybersecurity vulnerabilities at the end of 2003. While working on this project, a position became available at the laboratory, and I joined the laboratory in February of 2005. Today's session is cyber risks to ICS. And we will cover the following topics: the risk curve, threat trends for ICS, adversarial risk, OSINT and OPSEC risk, case studies or practical examples, and basics to determine ICS critical cyber risk. DHS does not provide any warranties for information I will cover today. DHS does not endorse any of the products or services, and any reference to such does not constitute an endorsement. Training personnel do not discriminate on the basis of color, race, religion, national origin, sexual orientation, physical or mental disability, or gender expression identity. Continuing education credits, CEUs. You will earn 0.1 CEUs for attending this presentation. 0.1 CEUs is equivalent to 1 continuing professional education credit. If you have a certification that you need continuing education credits or CPEs, this is 1 CPE for that certification. This slide, Cyber Champ, was covered by Dr. Staley during the virtual fall meeting 2 weeks ago. And this maturity progression model can be used to map the competency health of your organization. Today's presentation is an introduction of cyber risks to the ICS environment and falls into the fundamental box on the right-hand side. During the ICS JWG meeting, some presenters touched on topics I will present today, but were covered at a more in-depth level. Risk curve. On the left side, we have the likelihood of an event, from very likely to least likely. And on the bottom, we have consequences caused by the event, from small to large. In the first section, we have group 1, anyone, and the likelihood is very high, but the consequences are generally small. This group is often referred to as script kiddies, who use existing malware to hack into computers rather than creating their own. Generally in class, I'll ask the audience, who has never had a worm or virus on their corporate environment? And I've never had anybody raise their hand. So this is a group that's most likely perpetrating those types of attacks or those types of infections into your environment. The second group, group 2, is comprised of cyber criminals, hackers for hire, insiders, and competitors. The likelihood of this group attacking your environment is less than the first group, but the consequences will be greater since this is a targeted attack, and they will have better skills and motivation. The last group, group 3, is nation-state actors and terrorists. An attack from this group is the least likely, but the consequences will be the greatest. They will be going after high-value targets to give them global notoriety. And these attacks can be supply chain, they can be debilitating attacks, and like I said, have catastrophic impacts. Threat trends for ICS. This graph was originally created by H.E. Lipton in 2002. Since then, we have continued to update it with current data. First, we have intruder knowledge, which had to be very high to begin with. But as the knowledge is shared and new ideas and techniques are developed, the intruder knowledge does not have to be as high. Second, attack sophistication, which started very low since there was no or little malicious code available at the time. But as tools became available from system administrators and program developers and placed on the internet, people with malicious intent started using these tools to exploit systems. Next, we have this purple curve. This new curve indicates a different intruder knowledge that was required for new attacks. This is the ICS knowledge. And once again, as these new attack tools were created and published to the internet, hackers downloaded the code, made modifications, launched attacks, and published the new code to the internet for the next attacker. A lot of ICS malicious code are variations on a previous attack package. We know that our systems, our control systems are 10, 20 or more years old, and we are limited in what we can implement to secure these systems. That is in direct contrast to our enterprise environments, where the systems are 3 to 4 years old, and we have training and tools to help us secure these devices and networks. So our challenge for ICS is to establish a zone of defense that will take advantage of the training and tools that are available within our organizations and apply them in such a way as to protect our legacy environments. Adversarial risk. We know that our networks are being mapped by nation states. China remains the most active and is responsible for cyber espionage against the US government, corporations, and allies. Russia continues to be a highly capable and effective adversary, integrating cyber espionage and attacks to achieve their political and military objectives. Iran continues to be a cyber espionage and attack threat. They continue to attempt cyber attacks against the critical infrastructure of the United States and allied countries. North Korea continues to use cyber capabilities to steal from financial institutes to generate revenue. Foreign cyber criminals will continue to conduct for-profit, cyber-enabled threat and extortion against the United States networks. Understanding the attacker profile will help identify potential attack goals and targets. Armed with this aggressor perspective, it is easier to identify and apply appropriate mitigations to minimize adversarial risk. Adversarial tactics and techniques. Here we have a progression list from MITRE ATT&CK knowledge base. So you can see initial access, persistence, privilege escalation, defense evasion. All of these different things are part of the attack profile and techniques. Also included a sample from the knowledge base from the link below in order to show you what MITRE has put together. For each of the boxes in the list, there are techniques and descriptions for each goal. OSINT, Open Source Intelligence, is the gathering of information from publicly available sources. There are many tools and techniques available for gathering this information, such as social media, Scans.io. These are different tools that are available. Census.io, deviceinfo.me, you have robots.txt, Google Hacking, the Wayback Machine, and Built With. There are also the traditional tools, Nmap, NSLOOKUP, Dig, etc., that can be used on the network to gather information. It's not just what you put out there, but what is publicly available about you. Be aware of the information made available by regulatory agencies, from contracts, the FCC, and mobile and wireless locations, such as Antenna Search and Strava. OSINT Framework, located at osintframework.com, is a collection of some of the most used OSINT gathering tools compiled into one handy website. Here on the right is an example from the web link below. Operations Security, OPSEC. Loose lips sink ships. We have all heard the saying. Today, the statement has similar relevance for the protection of our critical infrastructure. 80% of all intelligence is unclassified. This data can be used by adversaries to effectively plan to disrupt operations. OPSEC is a process, not a set of rules. OPSEC should be part of your cybersecurity plan, should be integrated and synchronized throughout the organization. Here's an example of what can happen when an organization is attacked.
Donc lundi 18 mars ce soir, nous avons été victimes d'une cyberattaque qui a instantanément paralysé tous nos postes de production. Car comme nous sommes sur un site intégré, tous nos outils sont pilotés par l'informatique. Donc tout s'est arrêté, de l'extrusion, la rupture de pont thermique, les chaînes de laquage, le magasin automatique et les expéditions. Tout de suite, les équipes ont réfléchi à savoir comment repartir en manuel. Toutes les équipes ont travaillé en commun pour trouver des solutions, la production, la maintenance, l'informatique, afin de débloquer des systèmes locaux, dépanner, inventer des nouvelles solutions pour imprimer des étiquettes à partir d'impression d'écran par exemple, et pouvoir tracer la matière.
Une des conséquences de cette cyberattaque a été l'arrêt immédiat de tous les serveurs. En effet, les communications entre les systèmes d'information SAP et CIDEL ont été interrompues. Le lendemain, nous avions un objectif, c'était faire redémarrer la production pour servir les clients. Nous avons checké SAP qui fonctionnait, CIDEL fonctionnait, mais ne communiquait plus. Nous avons fait créer par les équipes de Comalu un outil permettant d'intégrer en masse les données extraites des SAP. Aujourd'hui, CIDEL fonctionne normalement sur le dépôt de Toulouse. Cette méthode a été transmise au site de Puget, Bonneuil et Courmel. Ceci nous a permis de reprendre la production et de livrer les clients.
L'essentiel pour les clients industriels a été de mettre tout en œuvre pour éviter l'arrêt de production. Donc nous avons mené 2 opérations en parallèle. La première a consisté à expédier tous les disponibles à quai afin qu'ils puissent continuer à produire. Et en parallèle, nous avons mené une opération manuelle sur le magasin automatique de Bonneuil afin de pouvoir leur livrer les références critiques et de façon à éviter encore une fois que leur activité soit interrompue.
Donc ici, nous sommes au service transport. C'est dans ce service-là que nous envoyons la charge à préparer journalière aux équipes du dépôt central, accessoires et profils. Cette charge se faisait en automatique avant le crash. Et aujourd'hui, nous sommes obligés de le faire manuellement. Donc tout ça, ça prend énormément de temps, c'est-à-dire qu'une charge avant qui était traitée dans l'instant T, aujourd'hui il faut 3-4 heures pour qu'elle soit descendue au dépôt central et qu'on puisse pouvoir se travailler.
Physical OPSEC, gates, guns, and guards, the 3 Gs. These are necessary in many places and go hand in hand with good cybersecurity. Physical access to cyber assets can be the easiest way to compromise your networks. Security topics, IT versus OT. From the IT side, we have the CIA triad, confidentiality, integrity, and availability, with confidentiality having the highest priority, followed by integrity and then availability. When we move to the OT side, the order is reversed, with availability having the highest priority. This is where our revenue is created. Many OT environments are operating 24/7, 365 days a year. Any downtime costs the business money. Patch management is a high priority for the IT department, where patches and updates are applied as soon as possible. Since availability is the highest priority in OT, applying patches are a lower priority and must be done during scheduled outages. The IT personnel must have current capabilities to support devices that are less than 5 years old, while the support for OT requires knowledge of systems 10, 20, or more years old. Secure system development is the normal part of the IT environment. Vendors understand the need for strong cybersecurity and continue to incorporate enhancements and updates to their products. OT vendors have been slow to follow the IT vendors since reliability and availability are still the highest priority for operations. Merging of IT and OT has created the use of newer operating systems, network applications, remote access, and other technologies into the OT environment. IT staff are being given the responsibility of securing the OT networks, and they are introducing these newer components into the OT environment. This has some interesting challenges, since the IT staff must now understand the needs of operations before they can successfully apply the cybersecurity measures they use for the enterprise side of the company. Recommended practices. CISA has some very good documents available on their website. Here are just a few. We have the procurement language guides, one for the energy delivery systems, and another one for control systems in general. They also have a secure architect design. Follow these links to the documents. Now let's look at some case studies or examples of cyber incidents. Polish trains. The threat is group 1, which we talked about earlier. Here we have a young Polish teenager who went and modified a TV remote and hacked the Lowe's tram system back in 2008. The impact was 12 people were injured and there was 4 derailments. The 14-year-old got into a tram depot and gathered enough information to build a device that allowed him to manipulate the tram system. When asked why did he do it, he said he was doing it for a prank. So, lessons learned. Do not rely on protocol obscurity for security, and apply appropriate access controls to all field devices. As I stated earlier, physical access allows you to take and have a lot of control over the cyber assets. Next, Bingham County server ransom. This is threat is group 2. Here we have extortion. So in February of 2017, in Blackfoot, Idaho, hackers found an open port and brute forced a password. The impact was that the county computers were inaccessible for 3 to 4 days. The hackers went and demanded $28,000 in ransom in Bitcoins. Fortunately for the county, they had most of their servers backed up and ended up paying 1 Bitcoin in order to get back the information off of a few servers that they didn't have backed up. So, lessons learned. Backups are essential. Strong passwords are required and necessary. No unnecessary ports should be open, and be sure that you have good firewall policies. LA traffic lights. Once again, group 2. This was malicious insider. In 2006, disgruntled traffic engineers hacked into the city traffic control computer. The impact was that they shut down traffic signals at a critical point, at 4 critical points, in the road network, causing crippling delays. Specifics. It was thought that the engineers would be sympathetic to the pay bargaining that was going on, and the administration even changed out or locked out the engineers from the system, they thought. As it turned out, that wasn't the case. These engineers were caught. One served time for the incident, and the second engineer, I believe, is still working for the company or was returned to work for the company. Lessons learned: do not underestimate the insider threat, and ensure separation of duties and auditing. Role-based access control, RBAC. This is something that we stress highly, and the use of an Active Directory or something that helps you ensure that you have groups that are separated from each other. It also allows you, if necessary, to terminate people within the group and terminate their access. Next one, coffee maker attacks. So threat group 2, once again, this is a ransomware. In 2017, a petrochemical company in Europe was attacked through a smart coffee maker. Impact was the company was forced to re-image the control system computers. During the time, a contractor was restoring image to these computer systems. The on-site operator went and said he was going to go get some coffee. All of a sudden he came back and he talked to the person who was restoring the images and said, "You're not going to believe it. I have the same image on the coffee maker." So they went and investigated and found out that the coffee maker had been inadvertently tied into the internal control room network and the isolated Wi-Fi network. So lessons learned: know what is on your network, ensure air gaps through network audits, and create a rigorous backup program. Bowman Dam hack, threat group 3, nation state. Event occurred in 2013. A SCADA system for a small dam was hacked through a cellular modem. The attacker gathered information on water levels, temperature, status of the sluice gate. He was unable to manipulate any controls, only because they were disconnected for maintenance. Hamid Farouzi, 34, a hacker the FBI alleges, was working on behalf of Iran's Revolutionary Guard Corps. Remotely and repeatedly accessed the SCADA systems of the Bowman Dam in Rye, New York. This was a group of hackers that were, as the FBI investigated, trying to infiltrate a number of different systems at that same time, back in 2013. I believe it was something that went on between 2013 and 2016. Lessons learned: network architecture is important. Cellular modems are still being used, so pay particular attention to older technologies. Space station. When people say our system is air gapped, here the air gap was bridged. Virus through USB drive. In 2008, a virus intended to steal passwords and send them to a remote server infected laptops on the International Space Station for the second time. Created a nuisance to non-critical space station laptops. The virus did make it onto more than one laptop, suggesting that it spread via some sort of intranet on the space station or via a thumb drive. Lessons learned: because of human factors, no true air gap exists. For example, thumb drives, laptop connections, modems, VPN, all of these can be infected and can propagate some type of virus or other malware. What is it that we need to do? First, we must identify what is connected to our networks and create an asset management list. If we don't know what's connected, we can't go and investigate these devices. Through the times that we've gone out and done assessments, we have found that what the asset owner thought was connected was, for the most part, especially in the control system LAN, was not a complete list. With all the devices that are connected all the way out into the field, there are devices that get connected that aren't updated on any maps. We had students who told us their field techs are the worst because they have to get their job done, and they will connect things to the networks in order to get their job completed. A lot of times there may be something connected is not on any maps anywhere. So what we need to do is ensure that we have up-to-date maps of all the devices that are connected and the configurations for those assets. Once we have a valid asset management list, then we can look at the devices and see if there's any threat vectors. We can see if any of these devices have vulnerabilities. We can see if all these devices are up to date, patched as well as they can be, and make a list of all of the different types of things that are vulnerable so that we can move forward and try to do the next step, which is identify mitigations for all of these vulnerable components. So we can go in and try to block access to these devices. We can do workarounds, or we can fix them. What we need to do is to minimize the system exposure. So we want to make the gap between the vulnerabilities that we have and the mitigations that are in place. In summary, we covered the risk curve, threat trends for ICS, adversarial risk, OSINT and OPSEC risk, case studies or practical examples, and basics to determine ICS critical cyber risk.
Thank you, Gary, for the presentation. We'll now answer any questions that you have. Please note that not only do we have Gary Finco on the line to help us answer questions, we also have Kelly Johnson, who is another instructor, another one of our instructors. Remember, if you'd like to ask a question live, to please raise your hand. Use that feature. It's in the attendee panel next to your name. I'll see that and I will click on your name and call on you so that you can ask your questions. Kelly and Gary, we did have a few questions come in. Your first question is, on the threat trend slide, how did the attack sophistication increase while the intruder knowledge decrease?
I don't know if we've got Gary here or not, but basically as hackers created attacks, they placed the code on the internet to get notoriety. The next hacker would modify or enhance code, place that code on the internet, and the attacks got better and better. Basically, they just build on each other. So that's how both the sophistication ramps up. People just build on it, but overall knowledge, they're building on code that somebody else created. So overall knowledge, intruder knowledge kind of goes down, but their sophistication can increase.
Thank you, Kelly. Our next question is, do you have any more examples of train networks and systems?
Can you guys hear me now?
Yes, Gary, we can.
Oh, good. I answered that last question, and I guess I was muted for some reason. Okay. I'm going to try and answer the question on train networks and systems. I know that there's been a number of attacks on different major trains. I don't have them in front of me right now. What I can do, if we have your email address, we have a copy of these questions, I'll answer it offline and get the answer sent back to you. Sorry, I don't have it with me in front of me. Thanks.
And just so you know, we do have that capability. We will have the questions and answers that will be sent out in an email. Not only will you be able to access the recording, but you'll also be able to see the questions that were asked and the answers to them as well. Our next question is from Darren Harper. Do you recommend the NIST 853 controls or other guides standards?
853, a lot of that would be recommended for government. NIST is part of what government entities have to comply with. You have 82 is also for the IT side. If you don't have a standard that you need to comply with, there are many standards out there. I know DHS is working with a number of organizations to help build up question sets. If you are not aware, they have an evaluation tool called CSET, Cybersecurity Evaluation Tool. You can go out to the CISA website and then search for CSET, C-S-E-T, and it'll help you go through and determine a question set so that you can use as guides along with other standards that are available. Thanks.
Our next question, Gary, is can you add more current attack examples? Do you have any examples that you can add, or is that something you'd like us to send out as well?
I have a number of them that are part of our incident packages. Generally, I have them set up as far as sector. So if Yaron, if he would put in which sector he'd like the incidents for, I can go and organize it like that. But if he wants attack examples across more sectors, let me know and we'll put together a package for him. Thank you.
Thanks, Gary. Our next question is from Ty Hughes. Ty, would you like to ask your question live? You'll have to unmute yourself as well, Ty.
It's like Ty's saying his mic isn't working, but this is Kelly. I'll take this one. Ty says from the OSINT slide, could you elaborate a bit on what types of information the regulatory organizations may inadvertently release or publish about organizations, and how might this information be used by wrongdoers? So the first one that off the top of my head here, an example of that is like the FCC. So a lot of times if you are trying to either release a product, a lot of these wireless things that are used in industrial controls, anytime you're trying to build a product that has that, you've got to go through the FCC. Now the FCC, whether it's a device or whatever, you can go look up the FCC ID. So there are lookups online, and a lot of times those will give you the spec documents on how the device was built. It'll give you pictures of both the outside and inside of the product, including like the board and the chips that are being used. It'll give you details on the hardware, the specs. So all that type of information is freely available. There are steps that organizations can take to, kind of black out some of that information, but they have to go a little bit above and beyond to do that. Along with the FCC there, one thing that was pointed out is antennasearch.com. It's just a website there where you can go in and pop in an address. Basically how this website works is you can put in a physical address and they'll return you a 2-mile radius of all of the antennas and towers that exist in that space. And they will tell you, for example, if it's a tower, a radio tower that's going to have a number of antennas, it will tell you the location of that tower, and it will tell you also the location of every antenna on that tower, how many feet up it is on the tower, what that antenna is used for, what transmitting frequencies it is using, and it will also give you owner information. They'll give you typically a name and contact information for people that own each of those towers and antennas. So opens the door a lot for social engineering. There's really quite a bit of information that can be gained there for attackers to start looking at those frequencies that are being used, the technologies that are being used in these types of products, to either try to mount physical attacks or really social engineering is the low-hanging fruit there.
Hi, Kelly, as an add-on, FERC requires their asset owners to submit yearly information about their networks. So this is from the energy side, transmission. Asset owners have to make updates as to accurate description of their networks. So that's a requirement that's there. It's publicly available also. We did one on pipelines that I can't talk about, but there is also information available on pipelines that's out there. So there's a lot of information that's just made available because federal government is requiring that. That's a good question.
Our next question is, are there any documents from basic ICS and cyber risk?
We have under CISA the online training that would, I think, incorporate a lot of the information on ICS and cyber risk. There's also recommended practices that are under the CISA website. Once again, just go in there and do a search. So that would be my first place for you to go and look for information.
All right. Our next question is, what are all the process and tools to be used to increase the gap between vulnerabilities and mitigation?
You got stepped on, Kelly. Jen.
Sorry.
Let me see if I can you repeat the question?
Yes, I can. Sorry about that. What are all the processes and tools to be used to increase the gap between vulnerability and mitigation?
I hope it's decreased, and he just went and mistyped. It's just standard cybersecurity, procedures. You want to do the first two parts, understand what's connected, understand all the applications, then go through and determine if there's vulnerabilities associated with those devices, whether it be OS, whether it be applications, and see if you have any mitigations available, as in patches, as in updates, and make a list of what you can update, what you can patch, and then do that when you can schedule it in. If you get to the point where you still have vulnerabilities and issues, then you have to go and put together a plan for figuring out how you want to go and isolate or protect. You know, we always talk about the depth and defense in depth. This is where you need to put that in place. When you have something that is vulnerable and you can't do anything to mitigate, you may have to isolate. I know at the laboratory, we always use one of our, it's a microscope that was funded by government. And with government funding, once you've accomplished the task, you don't have any more funding. So in order to do anything, if we would have to go in for another set of funding to upgrade and bring that up to a different level of OS and everything. But as they say in Texas, if it ain't broke, don't fix it. That's what's happened with this microscope. It's on Windows NT. We don't have funds to take that up to a newer, more secure operating system. And so it's part of the laboratory, but it's totally isolated. In order to utilize it, employees have to either have something connected directly to that that network for the microscope, or go to the microscope. So those are the things that you'd have to do once you go and get all the understanding in order to decrease the gap between vulnerabilities and mitigation. Thank you.
Thank you, Gary. Our next question is from Al Scott. Al, do you want to ask this question live? Are you there, Al? All right, I'll read it. So it says, as an auditor of critical infrastructures, for example, drinking and clean water facilities, sewer utilities, flood facilities in New Jersey, this is of interest. Are there more known examples of compromised infrastructures available?
Yes, I have incidents for more water utilities, and excuse me, once again, I can send those out as part of the follow-up to this training course. Thanks, Al.
Our next question is from Tony. He wants to know, for cyber risk assessments, actually, I think this is a statement, excuse me. For cyber risk assessments, CISA has a cyber resilience review via the CSA program.
Yeah, I think Tony's comment there, and also Janine Shepard had piped in as well, just on some of the earlier questions on some of the assessments, documents for basic ICS and cyber risk, like where do you go for that type of information? I think Tony is kind of putting in, hey, you can reach out to CISA. They have that cyber resilience review. If you're not familiar with CISA's services, definitely go check them out. Janine had mentioned, the address there, www.cisa.gov/ICS. There are documents out there. There are contacts there that you can reach out to if there are assessment services that you're interested in. Not to total, sales pitch CISA, but it is a service. Their services are taxpayer paid, so free to your organization. So there are some great documents, some great things to get you started there if you're looking for where to begin in this space.
Okay, thank you, Kelly. Gary, do you want to add anything?
Ariel? No, I was just going to say Tony's a CSA with CISA with DHS, and Janine is also with the ICS-JWG program. So two resources from DHS.
All right. We do not have any more questions. Gary, do you have any further finishing remarks? Or Kelly, do you have any finishing remarks that you would like to say?
My only remark would be that we do have more online training. So if you have colleagues who were not able to attend this training session, to go out to the, and we'll send out the web link for that, where you can go out to our online training along with all the rest of the responses we're going to do for this. So it's there, it's free, it's being paid for by your tax dollars, and it's being presented by Department of Homeland Security, CISA organization. So that's all I got. Thanks for attending, guys.
Kelly, would you like to add anything?
Gary stole exactly what I was just going to say. You know, for more information, reach out to CISA.gov/ICS. So that's the industrial controls specific section there. And also, yes, check out our other online training. We've got a number of different sessions available. We also are continuing our 301 classes that, you know, a lot of people have participated. I'm sure a number of you on this call have participated in that before. Right now they are virtual, but we are continuing to do them virtually until we are able to do them in person again. But those still are available. We also have a new 401 course that is available virtually as well. That's follow on to 301, which some of this material we talked about today, OSINT, OPSEC, some of our adversarial risk is addressed in a little bit more depth in that class. So if you want more information, like Gary said, we'll send out the links, and hopefully we'll see you in a future training.
All right, thank you. I also want to thank everybody for attending today's session on cyber risk to ICS. Please make sure you register for next week's presentation, which will be on analyzing previously captured ICS traffic to discover vulnerabilities, and it will be part of our advanced educational track. And with that, we'll thank everybody for coming, and everyone have a great day.